Okay, guys, this is part 4, and I have to scroll back up because part 4 didn't take last time. So we're up here at physical properties. Remember, physical properties are things that we can touch, taste, smell. They're things that are intrinsic to that thing themselves. So, for example, metals are very different from nonmetals. We already know that already, which are very different from noble gases. And it's those properties on their own, not how they behave chemically, but how they are, that make it a physical property. Here's a reboot of a physical property that we saw from the metals vocabulary. One is malleability. I always remember it with the word mallet. Like you use a mallet like a hammer to pound things, and it's the ability to be pounded into thin sheets. For example, aluminum can be rolled and pounded into sheets to make aluminum foil, something you use in your everyday lives. A cool historical note: way back in the day when the monks were making, the very labor intensive copies of the Bible, they used to take very thin sheets of gold called gold leaf and sometimes put them on the edge of the pages because it was a sacred document. Ductility. You can kind of think of the ducts in your that run the air conditioner. They're big tubes, except these are much smaller because they're wires. So metal's ability to be drawn or pulled into a wire. So example, you have copper wiring, anything that's in a wire, that's the ability to do that is unique to metals, and it's a physical property of metals. Some more vocab for you: solubility, the ability to dissolve in another substance. We saw that in the M&M lab, how sugar dissolves in the water. That's a property of sugar, that it dissolves in water. Um, or that salt dissolves in water. Okay. And there are 3 ways to increase solubility, by the way. You can use heat. You know that from the M&M lab. You can grind it. We didn't really do that aspect of the lab, but you can. And stirring or mixing, which you should have kind of gotten from the lab too when you made your 3 different solutions. So solubility is a good physical property to talk about. And we'll talk about it more when I get back. States of matter. What temperature things have states of matter at is another chemical or physical property. Not chemical property, physical property. So that water's freezing point is at 0 degrees Celsius, at 32 degrees Fahrenheit. That it's that its freezing melting point is there at that temperature, and then its boiling point is at 100 degrees Celsius, 212 degrees Fahrenheit. That's there. Um, and so those are the temperatures between solid, liquid, gas. If we look at a temperature pressure graph, which you can look at later, you can actually see that sometimes solids turn into gas, and it turns out that I want you to write down in your notebook, pause the video right now, what is there a solid that you know of off the top of your head that turns directly into from a solid to a gas? Let's see if my draw. Let's see if we can. Is there a solid that will go from, will turn into a gas? And what is it? Oops. Sorry, my left-handedness has bumped me again. Let's turn off auto rotate. And if you think of the common name of it, has a very common name, find out what that chemical composition is. in your notebook. Find out what that is. It's a very common thing. So moving on. Thermal conductivity. Different items conduct heat better than others. Okay. Again, metal is generally thermally conductive, although we could run an experiment where we can find out which metals do it better than others. I did a very simple science fair experiment doing that and found out which metals were the best at the thermal conductivity than others. And others don't. Like, for example, you don't want certain things to be thermal conductors. Like ceramic for your mug is not a great thermal conductor. Plastic foam is a poor thermal conductor. These new vacuum metal is generally a good thermal conductor, but it turns out if you take two pieces of metal and put a vacuum between them so that there's no air between them, then you turn into a fantastic thermal conductor. I just got a new water bottle that keeps ice cold for 24 hours. Also the toast inside of a toaster, you apply electricity to the hot coils, and the hot coils conduct the heat energy to your bread or whatever you're toasting very well. We depend on the thermal conductivity of that. So those are the physical properties. Okay. So then we have the chemical properties. Okay. Chemical properties are not the things that you can touch, taste, see. They're like the internal hidden properties of something. You don't look at a piece of wood and automatically know by looking at it that it's flammable. Now, you know that it's flammable based on your experiences in life, but you don't just know it by looking at it, right? Like if you looked at wood for the first time, you wouldn't be like, oh, that's flammable. So a chemical property is a property of matter that describes a substance based on its ability to change into a new substance with different properties. So one is combustibility. Okay, if you don't know the answer, you don't know the definition of that, please take a moment and look that up and define it. Flammability. We talked about that one. Reactivity is a chemical property. The fact that baking soda and vinegar can react to do what it does, the bubbles that it famously makes when we add baking soda and vinegar together, or Mentos and Diet Coke. And no, we cannot do Mentos and Diet Coke in class. Sorry, I'm at home and my dog's bothering me. Okay. That again is a chemical property. So we'll talk about these later, hopefully. We have acids, we have bases, we have the idea of oxidation. Those are all chemical properties. Some big picture things about chemical properties is that, as I said before, they cannot be, they can be observed with their senses, but they're not as easy to observe as physical properties. So example, flammability, you only know that when you stick a match to the wood, correct? Combustibility only when fireworks explode, and reactivity only when iron oxidizes. So if you find a new piece of iron versus an old piece of iron, then you might ask yourself, well, how did that rust get to be there? So not only do we have chemical and physical properties, we have chemical and physical changes. Okay, so when we have a physical change, that's a change that affects one or more physical properties of the substance, but does not form a new substance. Okay, the key here is that it does not form a new substance, and often it can be undone. Okay, not always. But one of the rules that you can think of in your head is, can this be undone? So, for example, butter that's slightly melted on the counter can be placed back in the refrigerator and it firms back up. Change of state, you get solid to liquid and liquid to gas. Okay? So right now we are out of time for this video. So, we'll have one more video on chemical changes and the 5 signs of a chemical change. And these will be the notes for this unit. Hope you're having a great day.